So here we have the short stack encased in its bulletproof Tupperware.
Very bulletproof Tupperware.
These two lines connect across motors PTO and SBO, and we're going to close this relay in the middle of a hill while it's flying crosswind, and then take data to see how the motors respond and how the system responds.
Yeah.
The 8+8 dyno, each one of these acts like a motor and a prop. So for each of these 8 setups, one side is the yasa that we would have on the kite, and the other one is a motor that is pretending to resist it as a prop. For shorting out a stack level, if we were to have a motor on the kite, fireball, or if we were to have a prop brake, then we would probably see some combination of the voltage on that level going crazy and a bunch of errors pop up. And we would not be able to continue to fly the kite as long as that level continued to be part of the system. So the short stack, by shorting a relay across that level, removes it from the system, and then you can take the remaining 6 motors on the other 3 stack levels, and you still have enough power that you can transition out of crosswind and hover back onto the perch without damaging the kite.
So Sophie has developed the code, the firmware and the board to, handle the logic of, oh, I see a command telling me to short out this level, let's short it. And we're now in the stage where we're examining how the system behaves. We've run a few hand tests where we just command the motors to a certain speed and torque level, and then we force strip any of the levels really. And Sophie has documented, what kinds of current waveforms we see in that transient moment, and that's led to improvements to the firmware. But now we're trying to do it in flight, so the hiddle. So we're doing the whole crosswind thing and shorting a level, and we started off at low power with that, and we're progressively expanding the envelope.
Is this especially important to do right now for any reason?
It's pretty important.
Well, people are really concerned that if we experience a motor failure in flight, which a lot of people say the only reason we haven't seen that yet is because we haven't accumulated enough test hours. So if we see a motor failure in flight, at this point we lose a kite, and losing kites obviously sets our schedule back. So if we got this thing on the kite in time to be able to survive such a fault, then it would save a kite, and it could save us several weeks of work.
Yeah, for sure. Don't be startled.
There will be a clunk.
That. Great. That was actually a good test. So that's the highest power hiddle we've done with the short stack. We were pushing around 300 and something kilowatts when the level was shorted. And the system works nominally, which is good. So Sophie will continue to do higher power for future tests, for which there needs to be some setup change. Yeah. And Sophie has the data pulled up already.
I do, yeah. We got a nice, clean, short.
We stayed almost entirely in generation once in crosswind.
Yeah.
Yeah, that's pretty good. Excellent, yeah. It did work. So, just more power, more relays.
Yeah.
We expect some of them to blow up.
It's fun to be working on something that could be a new part of the kite, and that could potentially save us from what has been our biggest downfall lately, which is hard landings that set us back. Yeah, how about you, Jesse?
It's fun work, you know? Don't get that everywhere. Yeah, so that's my piece.